What's up, Finitians? Here we go into Chapter 6, Set and Set Notation. We are going to be taking a break from crazy number type stuff and basically working on relations, and it's going to help us with probability and some other things. So it's going to look a little different, these next few topics, but it'll all be okay. Okay, so our essential question: how do you find the union, the intersection, and the complement of a group of sets? First off, a set, all right, for us, it's just a collection of distinct objects treated as a whole thing. For example, you might have the set of whole numbers. For our case, they may give you, okay, it's notated as, so we'll say W is, we can say whole numbers such as 1, 2, 3, 4, 5, 6, 7, so on and so forth. Okay, maybe the set is superheroes, in which case S is, I don't know, some superheroes. Superman. Okay, you would have, of course, Wolverine in there. Wolverine. And really any superheroes you can think of. All right, those are just kind of what we're talking about. We will be using numbers, we'll be using items, names, everything. An element is a member of a set. So examples: Superman is an element of the set of superheroes. 1 is an element of the set of whole numbers. Okay, elements of S in that case, as I just said, those would be Superman, Wolverine, etc. All right, so those types there. Special sets. So some special sets here, we have the null set, or the empty set it's called. And it's a set with no elements, okay? Sometimes we use this here, okay? Symbol of O, or you might also see it as this here with brackets, okay? Same thing works for me. The universal set, on the other hand, is kind of like the entire universe. Yeah, you can't use the same word. The entire amount of objects that we are considering. So I like to give examples of animals. So like if we were considering the animal kingdom, okay, as our universe, okay, like that. So as our universe is the animal kingdom, then all of the sets that could come out of this would be like your mammals, your birds, and so forth. Okay, but animal kingdom would be the largest set of all of them. There are relations to consider between pairs of sets, and this is where kind of the algebra and the work comes in. First off, if sets are equal, they have to have exactly the same elements. Okay, so A equals B means they have exactly the same elements. For our example, if we were to consider lion and tiger and bear and wolf, okay, they're the same thing whether you have it lion, tiger, bear, wolf, or if you have it opposite. So just for example, lion and tiger is equal to tiger and lion, okay? Doesn't matter what order. Sets that are not equal, they just don't have the same elements. They are just not the same. They don't have the same elements. Pretty straightforward, I would like to think. Subsets. These are what can get a little more confusing. Subsets and proper subsets. A subset is a part or whole of another set. Okay? So think of it maybe if we look above here. So when we look at the universe, lion, tiger, bear, wolf, gorilla, zebra, giraffe, cheetah. Okay? How we would write this is if we consider A. So A is just lion, tiger, bear, and wolf. A is a subset of U. Okay, each of these elements is within U. So A is a member of U. Now, we could also say for proper subset, U is also a proper subset of, U, okay? They have all the same elements. The difference between that and proper subset, it is just a part of another set. Think of it as an equal to sign. Here you can have the sets be equal to each other. Here you can't. So A is also a proper subset of U. Okay? But it's not, U is not a proper subset of itself. What? You might be confused. It'll be okay. Just think of this as long as the elements are a piece or a part of one another, then you're okay. Alrighty, so some operations to consider here. Operations of sets, we're going to use the same things. Union means to add the elements together. So we're going to add the elements of each set. Okay, so A union B means we're going to take lion, tiger, bear, and wolf. And if we wanted to union that with gorilla, zebra, and giraffe, I have an extra E on there. Oops. This entire set will just be all of those elements, boop, 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 in one. So we would have lion, tiger, wolf, bear, wolf, gorilla, zebra, giraffe. It's almost like you're adding the sets together. Think of it as a plus sign. The intersection is what are shared. Okay, so these are elements that are in both sets. So if we were to consider A and C, okay, let's look up here at A, lion, tiger, bear, wolf, and C, tiger, cheetah. If we were to look at those two, what do they have in common? The things in common between lion, tiger, bear, and wolf, and tiger and cheetah are the tiger. They each have tiger. Okay, so in that case there, the intersection is, so A intersect C equals just tiger. Wow. Complement. This means not. So everything but A. Okay? And it's important when you're using the complement that you consider the universe. So consider the universal set. Okay? So basically, if we look at lion, tiger, bear, and wolf, that is what A is. The complement of A, I'll just write them all down. You're going to compare to the universe. Okay, so the complement, the little hat on top, is the set of everything from the universe. That's not lion, that's not tiger, that's not bear, that's not wolf. Okay, its complement would be gorilla, zebra, giraffe, and cheetah. Okay, so that's the basic idea there. If they don't have anything in common, then the sets are called disjoint. Okay, sets that don't have anything in common are disjoint. So for example, A and B have nothing in common. Lion, tiger, bear, wolf have nothing in common with gorilla, zebra, and giraffe. Okay, so practice. Use the following. I'll give you some time to do this. I'd like you to pause the video, and try these out. When you're done, okay, restart it and then see if you get them correct, okay? So I will go through them, but give it a shot, okay? So first you're finding C. C is not, so you want everything not C, okay? Well, C is B-I-V-Y, so from R-O-Y-G biv, I don't want B, I don't want I don't want V, I don't want Y. Okay, that means I want R-O-G. Pretty cool. Okay. Not D. So not D means everything but D. So no Roy. So in that case, I want G biv. Okay, C-U-D means to take C and add the elements of D. So I'm going to have B-I-V-Y and R-O-Y. You don't need to repeat them. So B-I-V-Y, R-O. And not C-U-D, I'm going to take not B-I-V-Y, R-O. Compared to the universe, okay, if I cancel out B-I-V-Y, R-O, I'm going to have G. How'd you do? Okay. We'll be doing lots of practice with these in the future. Okay. So at this point, I'd like you to just kind of check your answers, see how you did, see how confused you are, and of course I will give you some more practice from there. So at this point, just kind of raise your hand, I'll give you the rest of the notes, or if you're watching at home, just stay in class stay ready for tomorrow. All right, awesome stuff. Have a good day, everybody.